Okay, pretty much. So what we're going to do is we're going to go actually back to about grade 7, grade 8, and we're going to review some basic words because if you see the word factors in a question and you don't know what factors means, you now can't do that question. So we need to go back and learn all these words again. So the first thing we need to learn about is number systems. Okay? So your naturals are 1 and up, wholes are 0 and up, integers are the negatives, the 0, and the positives. What you should notice is naturals, wholes, and integers have no fractions and no decimals. So if you're a fraction or a decimal, you can't be an integer, a natural, or a whole. Now, what a lot of kids get confused on is whole versus natural. So naturals are 1 and up, wholes are 0 and up. The way I have always taught it is the word whole has the letter 0, and 0 looks just like the number 0. The letter O looks just like the number 0. So wholes are 0 and up, whereas naturals are 1 and up. Okay? Rationals, this is where all your fractions go to die. So if you have a fraction, okay, if you have a decimal, now I refer to them as happy decimals. Happy decimals are a decimal that you see on your calculator and you go, huh, that's not so bad. 0.5, 0.3 repeating, 0.121212. You don't look at it and go, oh, what is that? Those are ugly decimals. Happy decimals literally make you happy when you see them. The key with rationals is rationals are also any integer, any whole, and any natural. So when we talk about rationals, a rational number is any number in this egg. So if you have the number 7, 7 is natural, 7 is whole, 7 is an integer, and 7 is rational. If I say negative 2/3, negative 2/3 is only rational because it's a fraction, so it can't be natural, integer, or whole. Now, do you need to classify numbers? No. But a question will say, list all the natural numbers less than 20. You need to know that that means 1 to 19, not 0. That's where we're going with this. If I say list all the whole numbers less than 20, then you write out the numbers 0 to 19 because wholes include 0. If I say list out all the integers from -5 to 5, you would list out all the counting numbers from -5 to 5, no fractions, no decimals. Okay, so it's just knowing what the general word means. Irrationals, we don't really worry about those too much. These are ones when you plug them into your calculator, you get out a horrific looking decimal. It doesn't pattern, it doesn't repeat. She's just nasty. She makes you go, ooh, right, when you look at it. Okay, now notice irrationals are their own separate egg. So meaning that if you're irrational, you can't be anything else. Like if you're whole, you can't be irrational as well. Okay. So I just wanted to go through, really, these are the only two you need to really concern yourself with, are naturals and wholes. Wholes include 0, naturals do not. That's the key takeaway for 30-2. Okay. Next key takeaway is prime numbers versus composite numbers. Your prime numbers are 2, 3, 5, 7, whoops, not 9, 11, 13, 17, and so forth. What makes a number prime is that there are only 2 numbers that divide into it. So how many numbers divide into 7? 1 and 7. How many numbers divide into 13? 1 and 13. How many numbers divide into 2? 1 and 2. Also, 2 is the only even prime number. Okay. So why didn't I write down 9? Well, what numbers divide into 9? 1, 9, and 3. So because it has more than 2 numbers that divide into it, these are the composite numbers. So these have more than 2 numbers that divide into them. So for example, 4, so 1, 2, 3, 4, 5, 6, 8, 9, 10, 12. Okay, those numbers have more than one number that divides into them. Okay, most numbers are composite and about a 3-to-1 ratio. So in the numbers from 1 to 100, there's about 75 that are composite and 25 that are prime, give or take. So if you had to guess composite, but when I say that, typically the diploma always picks prime numbers because prime numbers are more specialized, whereas composite are more general. Okay. So again, these are things that you should know. It's just that you haven't had to think about them for a hot minute. Okay. Notice I skipped over the number 1. 1 is neither prime nor composite. How many numbers divide into 1? Just 1, right? 1 only has one number that divides into it, 1. So in order to be prime, you have to have 2 numbers that divide into you. In order to be composite, you got to have lots of numbers that divide into you. So 1 is the loneliest number, and so it only has 1. So 1 is neither prime nor composite. Will that ever come up in a question? No. No. No, they wouldn't do that to you. Okay. Okay. Multiples versus factors. Okay. Easiest way to explain this is just to show you an example. Multiples are like your times tables. So if I ask for the multiples of 8, that would be 8 times 1, 8 times 2, 8 times 3, 8 times 4, and so on and so forth. Those are the multiples of 8. If I asked you for the factors of 8, these are all the numbers that divide into 8. So what are all the numbers that divide into 8? 1, 2, 4, and 8. So 1 divides into 8, 2 divides into 8, 4 divides into 8, and 8 divides into 8. 6 does not divide into 8, so 6 is not a factor. This one's a big one, okay? Asking you for the multiple of something versus the factors of something, they like to do that a fair bit, okay? Domain and range. So we're not going to worry about this whole second column here. We don't need to deal with that in 30-2. I didn't know that when I made up the sheet. So domain is always your x values. Range is your y values. So we've talked about domain and range with exponents and logs, right? We've already dealt with this. But just to refresh your brain, it's the number on the left and the number on the right. And if there is no left or right, we say x is real. And for range, it's the number on the bottom. And then you draw in your inequality, which always looks like that. Number on the top. And if you don't have a bottom or a top, in other words, if it goes forever, you write y is real. So the inequality looks exactly the same for domain and range. It's just, yeah, you just got to commit it to memory. You've seen it now for 3 years. It should be sinking in for you. And if it hasn't sunk in after 3 years, I got nothing for you. Okay? Domain and range isn't a big deal in this unit, but it does come up every now and again. But by far, multiples and factors, number systems, and prime versus composite come up way, 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 way more. Have I totally confused anyone yet? Okay. Okay, so Learning how to read the math, learning how to read the notation is going to be problem number 1 in this unit. Let me just erase this. You don't need that one. Okay, so it says list out the numbers given the set builder notation. Okay, so what a set is, a set is these fancy brackets. And all a set means, it's a collection of objects, usually numbers, because we're in math class, that satisfy a given condition. Okay? So for example, if I said, stand up if you're a girl. So all the girls stand up, and I would put set brackets around you. So I would go set Kaylee, comma, Amy, comma, Kaylee, comma, Abigail, comma, Reese, comma, Morgan. End of fancy bracket. Josh is not included in that set. Okay? So when we use those set, so now set brackets and just the regular round brackets mean something entirely different. So when you use round brackets, that doesn't mean set. So when you see those fancy brackets, that's a collection of all those objects. Okay? So you're going to see, because this unit's called set theory. So you're going to see the set notation again and again and again. So the way we read this, it says we would list out the set of x's. This little straight line here stands for such that. Okay, so list out all the set of x's such that, and then x is less than 8 and x is natural. So, oh, sorry, less than and equal to 8. Sorry. So, give me the natural numbers that are less than and equal to 8. So, natural numbers are what and up? 1. So, natural numbers are 1 and up. So, we're going to go 1, 2, 3, 4, 5, 6, 7, and we include 8 because of that equal sign. So that is the set of that notation. Now, if I said verbally to you, list out all the natural numbers less than or equal to 8, please, you would have no issue with that. Some of you may clarify, what's a natural number again? But you wouldn't really, it wouldn't cause you grief. But when you see how it's written mathematically, so I'm essentially going to be your decoder in this unit. I'm going to teach you how to read math. So you're going to learn a whole new language over the next couple weeks. Okay? But once you learn the language, it's there forever. Okay? So when I hear kids say that they're a math person because they do better with numbers, yeah, no, not in high school. The next 3 units are all words. They're all words. Now, oh, we're going to talk about a poem where the curtains are blue, and the question is, why were the curtains blue in the poem? And you're sitting there going, there was curtains in the poem? Right? Like you have no clue. That's not what we're talking about. When I'm saying that there's words in math, I'm talking about that, like a little symbol. We're not talking paragraphs. So in the last unit when we did half-life and doubling and compound interest, those paragraphs were getting kind of big. These questions are not even going to be close to that big. They're going to be much shorter, but they're going to be full of symbols that you don't know what means yet. So my job is to decode the symbols so that you can go, oh, it's just the numbers less than 8. I got this. Okay. So what does this mean? So this means it's all the x's such that x has to be less than or equal to 3, but x must be a whole number. So what are the whole numbers less than and equal to 3? 3, 2, 1, and 0 this time, because wholes include 0. Now, does it matter what order you put the numbers in? No. So sometimes you might 0 to 3, sometimes you write 3 to 0. I don't care. If you want to live on the edge and write 2, 0, 1, 3 and really annoy me, go right ahead. It will drive me wild, but I'm not going to stop you and you're still correct. Okay? So a little math language thrown in there with some good numbers. And then there was one I whited off your page. That's why this one's crossed off. You okay? Okay, now more often than not, instead of the symbols, they just give you the sentence. So, if I just slide this down again. Write out the numbers defined by the sets. So again, sets. So we want to write the answer as a set. So natural numbers, so this means 1 and up, less than 20. No, notice not equal to 20, just less than 20. And they also have to be divisible by 3. Well, what does divisible by 3 mean? It means that 3 has to divide into it, right, without leaving a remainder. So it doesn't matter if you start at the 20 or if you start at 1. It doesn't matter which way you go about this. I'm just going to start at 1 and count up till I get to 20. So is 1 divisible by 3? 3 is divisible by 1, but 1 is not divisible by 3. Is 2 divisible by 3? Is 3 divisible by 3? Is 4 divisible by 3? Is 5 divisible by 3? What's the next one that's divisible by 3? What's the next one that's divisible by 3? What's the next one that's divisible by 3? Next one. Next one. Next one is 21, but it's bigger than 20, so our set is done. How else could they have worded this question? List me the set of numbers that are natural, less than 20, and are multiples of 3. So asking for the multiples of 3 is the exact same thing as asking for numbers that are divisible by 3. So I've mentioned this to you before. I might word it as divisible by 3. The workbook might say multiples of 3, and the diploma could go either way. My job is to let you know that they both mean the same thing, and you interpret it how you interpret it. Okay, natural numbers less than 40 that are multiples of 6. So like I said, another way to say this is multiples of 3. Another way to say this is divisible by 6. Whatever floats your little boat. Okay. I find that most students prefer the multiples word versus the divisibility rules. The reason for that is when you guys learned math in elementary school, the first thing you learned was add, the second thing you learned was subtract, the next thing you learned was multiply, and then they took off a couple of years and then they taught you division. So when you guys see divisibility and you think of division, it's the last math concept you learned because it was the hardest. But multiply is way easier for you. So natural numbers, so 1 and up, multiples of 6, so that's 6, 12, 18, 24, 30, 36. Now, I will say this, you're not allowed to go dot, dot, dot. So you're not allowed to go 6, 12, 18, dot, 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 36. You have to list all the elements. You're going to hate me for it, but you have to. These are quite possible diploma exam style questions. Oh, before I go any further. So these next 3 units, ready for this? These next 3 units make up over 55% of the diploma exam. There's more questions from, okay, so this unit's only 3 lessons long, okay? Our rationals unit was 9 lessons. This unit will have more questions on the diploma than the rationals unit. That is good news for you. For those of you who hated the algebra but can do this, fantastic. Okay. Also, the diploma starts with this unit. So this is the first thing you're going to kind of see out of the gate. Okay. Okay. Prime numbers less than 15. Okay. So what's your first prime number? 2. And then 3, 5, 7, not 9, 11, 13. Next one would be 17. So there's my prime number is less than 15. Whoops. Factors of 40. So factors is all the numbers, all the numbers that divide, that divide into 40. Now, what I suggest you do with this is start counting and list them out in order instead of just willy-nilly putting numbers down on your page because you might miss some. So does 1 divide into 40? Yep. Does 2 divide into 40? Yep. Does 3 divide into 40? Nope. Does 4 divide into 40? Does 5 divide into 40? Does 6 divide into 40? Does 7 divide into 40? Does 8 divide into 40? Okay, right here. You see how you go 5 times 8 is 40? Right? What we do is we call this a halfway pair. So now all I have to do is figure out the next halfway pair. Well, 4 times what is 40? 10. 2 times what? 20. And 1 times what? 40. Because here's the thing. We don't want you going 8 works, 9 doesn't, 10 does, 11 doesn't, 12 doesn't, 13 doesn't, 14 doesn't. We don't want you counting all the way up to 40. You'll be there for days. What if it was 400? Right? You don't want to count to 400. So what you do is you look for your middle pair, right? So once you get to that point of middleness, then you just start building from there. Okay? This is not a very popular question. They like primes, they like multiples, they like divisibility, but they don't often hit factors too much. But it's technically fair game, so that's why we're going through it. Okay, Crash Course 101, some grade 7, 8 review there to get your brain warmed up. You will notice that all the numbers are going to come back. Okay, so we're not going to be solving for X, we're not using graphing calculator at all. It's just words. So that second sheet that I handed out to you, it's called a terminology sheet. What I've done is I've broken down each lesson into the key concepts for each lesson. So lesson number 1 is the one we're doing today. I've just broken down what the key meanings for today. So essentially this is a cheat sheet for you so that you can kind of have it as a quick summary guide for what we do each day. Okay? Okay. So let's go into our workbook and we're going to go to page number 1. We're going to start all the way off at the start. Okay. So if you look at your workbook here, if you look at page number 1, and if you flip to page 2, and if you flip to page 3, it's just words and words and more words. Okay, this is why I don't like this unit, because it looks terrifying on the page. But when we go through it, it's ridiculously simple. It's just often in math to describe something takes a lot of language, right? But to actually do it, it's simple. Okay, so let's start out with the first thing. And the first thing is statements. Statements are something that has a truth value. I love math. That is a statement because it's either true or false. Okay, it is sunny out today. That is a statement. It's either true or false. And we're not going to play the Trump tactics where there's different types of facts. It's either true or it's false. It's black and it's white. There is no gray in math class. Okay, none. Okay. A statement is a fact. Now, the fact could be true or the fact could be false, in which case it's no longer a fact. Okay, but they are true statements. So the city of Vancouver is in the province of BC. That statement is true, and it's a statement. It's true or it's false. The city of Vancouver is on the planet Mars. That is still a statement, it just happens to be false. Vancouver is the best place in the world to live. That is an opinion. That is not a statement. So statements are just something that are either true or false. Okay? Nothing's up for interpretation at all. Okay? How do you get to Vancouver? That is also not a statement. It is a question. Even if there's only one answer, it's still a question. It's not a statement. So if you write something down, if there's a truth or a falseness to it, and it's one or the other, again, no gray, then what you've just written down is a statement. Okay? I have 12 pairs of shoes in my closet. That is a statement. Okay? My brown shoes are my favorite. That is not a statement because that's up for interpretation. Okay? Okay, so I don't know why all these are shifted so high. So determine whether each of the following is a statement. For each statement, list its truth value. The number 4 is prime. Is that a statement? And is it true statement or is it a false statement? This is a false statement. Driving in a car is the best mode of transportation. Is that a statement? Nope, that's an opinion. If you double an odd integer, you get an even integer. Okay, well, think about that. Think of an odd number. Got it? Double it. Did you end up with an even? So this is a statement. And the statement also happens to be true. Okay? If you just think of statements as something that are either true or false, that's it. Okay? See, all those words on the page boil down to it's something that's true or false. That's it. So that's what this little cheat sheet is here for. So I took all the words on page 1 and I made it into one line. So that's what this does. Okay? And if you lose this, there's one on Google Classroom. Okay? So I copied it and put it on there. Okay. The negation of a statement. Okay. Now, I'm going to preface this by just sharing a little bit about myself. Not too many people know this about me at all. When I was little, I had a brain injury in a car accident, and it was quite severe. It was a head-on collision, and my head collided with the windshield, and so I suffered a frontal lobe brain injury, severed my pituitary gland, gave me a whole bunch of health issues further on. And the main issue that I have is I can hear the words in my head and I think I'm saying them, but sometimes they don't come out that way. So I might be thinking, so I was trying to explain to my husband last night that it's grad plus 3, but I kept saying grad has 4. But I knew it was grad plus 3 for a total of 4, but my mouth couldn't communicate what my brain had. And my husband was getting very upset with me. And I was getting very upset with him going, it's simple math. Like, and I was like counting on my fingers and he's like, no, you're missing one. I'm like, no, I'm not. And so that's my life. So in teaching, it can be an issue because I can hear it in my head, but my mouth won't always say what I mean. And I'll know when I do it because everybody's head in class goes, what did she just say? And I'll be like, what did I just say? And they're like, you said this. Okay, yeah, that's not what I meant. So I cover it that way. But for me, so reason why I'm telling you this is negations trigger that for me. Like when somebody says it is not, like there's that phrase like, well, he's not wrong. Okay, he's not wrong. Why don't you just say he's right? Right? Well, but it sounds more clever to say he's not wrong, right? Or not sorry, right? Like those nots, my brain, I have to literally stop, put my pencil down and go, what does those two things together mean? And I have to write it in the affirmative because I can't think in the negative. So I'm going to teach you this, but please don't ask me questions because I don't do this. I can't make this make sense. So when you get the negation of a statement, all it means is that if your statement is true, the negation of the statement has to be false. So the statement was, Vancouver is in British Columbia. That statement is true. So you have to come up with a statement now that is false. So you could say, Vancouver is not in British Columbia. That would be one way to say it. Or you could say, Vancouver is in Alberta, because that's false. So the negation of a statement is something that has the opposite truth value. So give me a statement that's false. 4 is a prime number. That's false. So give me now a statement that is true. 4 is not, or you could say 4 is composite. So same topic, opposite truth value. Okay? So a not statement or a negation statement is just the statement with the opposite truth value. So Melissa is the best assistant in this building. True. Hard true, right? Hard true. Now give me the negation of that. Lisa is the worst, or Melissa is the worst EA in the school. Or we could say this, we could say, Lisa is the best assistant in the school, right? So we could say something like that that goes against her truth value. I'm not saying Lisa isn't, sorry, that was terrible. But my point being is that when you're doing a negation, you don't have to see the word not. It could just mean the opposite, right? When I said 4 is prime, one answer is 4 is not prime. The other answer is 4 is composite. They both are correct. Okay, so when we talk about negations of statements, that doesn't always mean use the word not. It just means make sure the statement has the opposite truth value. Okay, whoops. Okay, so a student made the following false statement. So this statement is false. All triangles are isosceles. So that is false. So that means it says which of the following below is the negation. So we need to figure out which one is true. Which one is true? All triangles are not isosceles. No. Can some triangles be isosceles? Yes, so that one's not it. Not all triangles are isosceles. Is that statement true? Yes. This one's true. This one's false. This one's false. Okay. Now, is that a diploma exam question? Haven't seen it. So actually these questions on the diploma, like I said, these are the first set of questions we see. And on the last diploma, kids sailed through it. It wasn't an issue for anybody. It's just learning what the notation means. Okay. Okay, write the negations of the following. So again, you can use the word not or not. I guess it's up to you. So it is 20 degrees Celsius outside. So right now that is false, right? It's cold. So what would be a statement that's on the same topic, but it must be true? You could either say it isn't 20 degrees outside, or you could say it's +1 outside, because that's actually what the temperature is right now. Okay. So notice one uses the words not, the other one didn't, but they're both still true on the same topic. It is not Saturday today. That's true. So you have to give me a statement that's false. You could say, it is Saturday today. What's another false statement you could give me? It's Thursday today. Right? Is there one answer that's correct? There's multiple correct answers. Okay. Okay, we'll take a little break, and then when you come back, we'll just keep going through this language. Okay. Okay, so negation of a statement is just, it has to have the opposite truth value. It doesn't matter if you use the word not or not, as long as it has the opposite truth value. Okay, compound statements. This is sounding like English class. A compound statement is two statements that are joined with the word and or with the word or. Now, in this course, and or become two of the most important words that we're going to talk about. So I'm going to focus on those two words a ton. And as we go through the units, you'll see why. Okay. So you don't have to know the word conjunction, but that's just two statements that are brought together with the word and. Okay. Melissa is smart and funny. Okay. So that's a conjunction. Okay. Okay. Your bucket's getting full. So blue is a color and ice is solid. So in this course, we don't care if the two things are related to each other or not. Like it doesn't matter that blue and ice have nothing in common. If you put two statements together and you connect it with the word and, we call it a conjunction. Now, a conjunction is only true if both the original statements are true. So in other words, is blue a color? Yes. Is ice a solid? Yes. Whoops, that's a true. So therefore, the and is also true. So when you bring two true statements together, we get another truth statement. Okay? Dry is a color. That's false. Ice is a solid. That is true. Therefore, the whole thing is false. It doesn't matter that one thing is true and one thing is false. If one thing's false, it negates the whole thing. Oh, whatever. Yeah. Dry is a color. Ice is a liquid. So this is where some kids get into a little bit of a pickle, because when we multiply two negatives, we get a positive. But when we use statements, two falses still mean false. Okay? So two wrongs still make it wrong. Okay? I've never seen a question on this, so we're just skimming through this. Okay, the word or. Okay. Here's the issue with it. If I say, I'm going to Dairy Queen and I'm going to order a Blizzard or a sundae, what does that mean to you? How many things am I going to order? One. Okay. In this course, it means both. Or is what we refer to it as inclusive. So or means one or the other or both. So I could order just the Blizzard or just the sundae, or I could order both. So or means one or the other or both, always. Okay. So it's like I could wear sandals tomorrow or a cardigan. I could wear both. I could wear sandals and a cardigan, or I could just wear sandals, or I could just wear a cardigan, or I could wear both. So or, that's the tricky bit, is we understand this or meaning one or the other, but in this course it means one or the other or both. Okay. So that one's a little dicey. Okay. So disjunction of two statements is formed by placing the word or between them. A disjunction is only false if both statements are false. If any part of it's true, then the whole thing is true. So Ivan rolled a pair of dice. Okay, so he rolled two dice. And he added the two numbers. Okay, he added the two numbers. And the sum was an odd number or a prime number. So what does this mean? Well, it means the sum was odd, or it was prime, or it was both odd and prime. Okay, so think of your two numbers, right? You got two dice, 1 to 6. right? So you roll one dice and it lands on a number. You roll the other dice and it lands on a number. What is one of the sums that you could have? If they both land on ones, what would the sum be? 2, right? If one lands a 1 and one lands a 2, what's the sum? 3. If they both land a 2, what's the biggest sum you could have? So the sums are going to be any number from 2 to 12. So if it's an odd number, that means the sum was a 3, a 5, a 7, a 9, or an 11. If the sum was a prime number, that means it was a 2, a 3, a 5, a 7, or an 11. If it was both odd and prime, so look at your two lists here. Which number appears in both lists? 3. What else? What else? So that's the 3, 5, 7, 11. So when he says I rolled 2 dice, the sum was either odd or prime, we're going to mean it could be odd, it could be prime, it could be both odd and prime at the same time. Okay? And it's this part that, because in this case it's kind of assumed, right? Like if I roll 2 dice and I landed on a sum, I have a 2 on one dice and a 3 on the other. The sum is 5. Is 5 an odd number? Yes. Is 5 prime? Yes. So I could argue it either way. I guess that's what that's saying. Okay? But or means one or the other or both. If we call it an inclusive use of the word. Now that's different than English class in some ways. Okay? So we just have to be cognizant of that. Okay, let's just do some examples here. Whoops, I didn't mean to do that. What the heck? I have no idea what's happening there. Anywho, okay. So it says consider the natural numbers. So we know what this means. This means 1 and up that are less than or equal to 15. So if we take those two thoughts, what is our set? So what's the set of numbers that are natural and that are less than and equal to 15? So just list them all. Okay. So 1 to 15. So from that list, which are odd? Okay. From that list, which are prime? That's a 3. Okay. All right. So here's where we're going to start focusing on some language here. And versus or. So when you see the word and, I want you to think of either the word both, and if you don't like that, think of overlap. So which are numbers that are both odd and prime? So is 1 odd and prime? No. Is 2 odd and prime? No. Is 3 odd and prime? Yes. Now, here's a cool thing that's going to happen. This is a list of everything that's odd. This is a list of everything that's prime. I want you to tell me the overlap. So do you see how 3 is in both lists? So if you just look through each list and you find everything that overlaps, that's the and. because it has and means both. So what's the next number that's in both lists? 5, then 7, then, yeah. So blue. So 3, 5, 7, 11, 13. Or means you're going to combine the lists because it means one or the other or both. So you're going to take these two sets and you're going to combine them. So so the number has to be from either list or in both lists. So we've got the number 1, 3, 5, 7, 9, 11, 13, and 15. So or means combine everything, and means just it's the overlapping. It's what's in both lists. And it's such a subtle word. If you're in the habit of when you see a math question, you skim read, you need to not do that in this unit. Please don't skim anything. Okay. Oh, because I forgot it. Sorry. My bad. Thank you for catching that. Okay. X is a factor of 3 or 5 or 7. So, looking at your numbers, what's a number that's a factor of 3? So start at the is 1 a factor of 3, 5, or 7? Is 2 a factor of 3, 5, or 7? Okay, so what's the first one? 3. Is 4 a factor of 3, 5, or 7? How about 5? How about 6? Yes, 6 is a factor of 3, so it goes on the list. How about 7? Yep. How about 8? Nope, 8 is not a factor of any one of those. How about 9? Yep. How about 10? How about 11? How about 12? How about 13? How about 14? How about 15? So remember, or means it's on one list or the other list or the other list. It's one or the other or all. Now look at the next one. X is a factor of 3 and 5 and 7. So what is a number in that list that would be considered a factor of 3, a factor of 5, and a factor of 7? Are there any? Nope. Okay, so when there's no answer, it's called the empty set. And the way we show empty set is 0 with a diagonal line through it. So don't leave the question blank, because blank means you don't know how to answer it. Because, like when you leave something blank, right, that I just assume you skipped it and didn't know what to do. Empty set means that there isn't any numbers that satisfy that condition. Okay. What is a number that's a multiple of 3 or a multiple of 5 or a multiple of 7? So the multiples of 3 are 3, 6, 9, 12, 15. So I'm going to write those in, leaving space to insert anything that I need. What are the multiples of 5? 5, 10, 15. What are the multiples of 7? 7, 14. There we go. So or means one or the other or both. Is there any number that's a multiple of 3 and a multiple of 5 and a multiple of 7? No. Okay. So do you see how when you do actually a number example, the or and the and kind of take care of themselves, right? It kind of makes sense based on the question. So this is where in math, when we try to describe with words, it's clear as mud. But when I do an actual example, it's like, oh, I get what you're doing now. And means it's on both lists. It's the overlap. or it could be on any of the lists. Okay, we're done. So on the assignment, just don't do number 5, okay? But any of it's fair game.